In this video we're going to look at graphs and functions, and we're going to see how we can manipulate these graphs quite simply. So let's take, for example, number 1. We're actually going to go through 6 examples of how we change the graphs. Okay, so we'll start off with example 1. Now if we take our function, we say our function y is some function of x, and let's consider it to be equal to x squared. Then we could take that function y equals f of x, and we could add a constant term onto a, so we have y equals f of x plus a. So in this example above, we would have y equals x squared plus a. So if we take an actual example for a, so let a equals 2. So when a equals 2, we would just have y equals x squared plus 2. Now let's have a wee look at that on the graphical tool here, which is a little graphical calculator called Desmos, which you can go and get online if you just hunt for it in YouTube. Just called Desmos. So let's say we had a function there, y equals x squared, and we're going to change that function. We're going to make it equal y equals x squared, and we'll add in a value. Now we could add in the value 2 so that it looks the same as the example we did. So if I put in y equals x plus 2, you can see it's taken this graph here and it's just shifted it up the y-axis. Okay, so what we'll do is let's take a general term. Let's say y equals x plus a, and then we can change the value of a by this little slider, and we'll be able to see what happens to it. So the blue one's the original functions, y equals x squared, and the green one is this new function, y equals x squared plus a. So there's a value of a there. So you can see when a is greater than 0, it shifts the graph up the y-axis in a positive direction. You see that going up. And when it comes down to 0, you'll just be back to the value y equals x squared, so it just sits on top of the original graph. And when you put a negative value in, you see it slides the graph down the way. Okay, so this y equals f of x plus a, all it does is it shifts the graph of your function f of x in the positive y direction if a is greater than 0, and the negative y direction if a is less than 0. Okay, so you can just download that and you can put these values in and you can try that for yourself. So let's go back and we'll have a wee look at the next section. Bring this back up again. There we go. So let's just see. Logism. Oh, Logism. No, smooth draw. That's us. So as you see, I've noted there at the bottom we have this f of x plus a. It moves the function up if a is greater than 0, and it moves the function down if a is less than 0. Okay, so that seems quite straightforward, I think. So let's go on to the second example. Let's say we have the function y as a function of x, which equals x squared. Now if we take that function and we, inside the brackets here, we add on this value of a, then we'll have y equals f of x plus a. So now what you do is, every time you see a value of x, you replace it with not the x, but the value x plus a. So that's just exactly what I've done here. In this example, I've taken the x squared and I've just replaced the x with the x plus a. So you get x plus a squared. Now an example of that would be, for example, we let a equal 2. So when a equals 2, we would have y equals x plus 2 whole squared, and we could multiply out those brackets. If you multiplied out the brackets, you would have x plus 2 times x plus 2, which would be x squared plus 4x plus the 4. So you can go and write that down yourself and multiply the brackets and convince yourself that you do get that. Now what's this going to look like? So we'll have a wee look and we'll see where this graph cuts the x-axis and where it cuts the y-axis. So we'll have a wee look here. Now we know it's going to cut the x-axis whenever the value of y equals 0, So we can write then that x squared plus 4x plus 4 is going to equal 0. So we know that that's x plus 2 all squared equals 0. So we know x plus 2 equals 0. So we know it's going to cut the x-axis at the point x equals minus 2. And we'll be able to see this in the graph, so we'll have a wee look just in a minute, we'll see it in the graph. And we know it's going to cut the y-axis when x equals 0. So all we need to do is put in zeros for the x's here. So we have 0 squared plus 4 times 0 plus 4 would equal y, so we just have our y equals 4. So let's get in and we'll put this into our graphical calculator. Okay, let's have a wee look. Well, Desmos, let's see, and there we go. So we'll get rid of that one there, and that there. So we had our y equals x squared. Now what we want to do is we want to have our y equals, and it's going to be our x, well, y equals x plus a value a squared. Well, squared, let's see here. Well, squared. Okay, now what again we can do is we can change this value a, we'll make it any value we want. So we know the example we did was a equals 2, so we'll put that value 2 in. There's the value 2. Okay, so we can see that the blue one there is the original y equals x squared, and the purple one there is the new one, which is x plus a squared. Now we'll notice whenever a is a positive value, it slides the function along in the negative x-axis. Okay, now we'll have a wee look and see what happens when we shift this a about. So if we make a even more positive, you see it's shifting the graph further and further along the negative x-axis. Okay, and if we go back to that value of minus 2, you can see it cutting the x-axis at minus 2. It's actually just touching the x-axis minus 2, and it's cutting the y-axis at y equals 4, which is what we expected. So if we were to then move this along to 0, and then we were to make this value of a negative value, then it would make the graph, make the function, push the function along the positive x-axis. Okay, so don't get mixed up with those. Okay, because and note that when a is positive, the function moves to the left, and when a is negative, that function moves to the right. Okay, when we've defined it as f of x plus a. So let's have a look, and we'll go on to the next little section. That's smooth draw. Let's see if we can get smooth draw up here. Oh, there we go. So I've just put at the bottom there what happens whenever we create y equals f of x plus a, then it will move the function to the left if a is greater than 0, and it will move the function to the right if a is less than 0. Okay, and I mean it moves it along the, I should say it moves it along the x-axis to the left and right. Okay, so now let's move on to the third one. If we had a function y as a function of x, and we can pick the value y equals x squared, then if we were to write this other function y equals minus f of x, then we would take the function x squared and we would stick a minus next to it. Okay, so just be careful, this minus is not inside this function. If the minus is inside the function, then this minus here would be inside the x squared. It isn't. The minus is just at the outside, so it's outside the function. So all you're doing is taking the whole function x squared and making it minus. Okay, now let's get in and we'll have a wee look at that. We'll see what that one does when we get into our graphical calculator. Okay, that's us back in, so we'll get rid of that there. We'll get rid of that. Now we're going to have y equals x squared. Now what we're going to do is we're going to put in y equals minus x squared. And you can see the blue one's the original one, y equals x squared. The red one's a new one, which is y equals minus x squared. So what we've done is we've taken the function there and we've reflected it in this axis. So just like the reflections in water, okay? So that's the surface of the water and that's just their reflection. So at point 1 will go to minus 1 and point 4 will go to minus 4, okay? So that's all that one does. So we'll go back to smooth draw and we can have a wee look at the next one. Okay, so I'll put a note in there that whenever we create the function minus f of x, it reflects the function in the x-axis. So on to the next one. If we had y equals, for example, y equals f of x, and I've no longer using x squared in this one. I've picked a different function for reasons that you'll see in a minute. So if I pick the function y equals x plus 2 all squared, now I can multiply that out, and we've already seen this one in one of the previous ones that we did. So that would be x squared plus 4x plus 4. Now if I create this new function here, and we call the new function y equals f of minus x. Now that minus sign is not outside here like in this one. The minus sign is now inside that function, okay? So it means that what we do is every time we see the value of x, we replace it by a minus x. So I've taken this function up here and I've replaced the value of the x with a minus x. Now when I multiply this out, I get x squared minus 4x plus 4. So what we'll do is we'll go and have a wee look at that in the graphical calculator and we'll see what that's doing, okay? So let's go f of minus x we're going to do. Okay, so Desmos and log in here. So I had this new function which I called y equals, in a bracket, y equals x plus 2, and it's all squared. Okay, so that's y equals x plus 2 all squared, which we've seen in a previous video. Now what we're going to do, we're going to create y equals f of minus x. So we're now going to have y equals, and we're going to have our minus x plus 2, and it's all squared. Now the colours are actually quite similar here actually. So this is the original one here, it's the light blue, y equals x plus 2 all squared, and this is the new one, minus x plus 2 all squared. Now you can see what's actually happening here is this function here has now been reflected in the y-axis. So all these points here are reflected over to these points over here. Okay, so for example that point there is minus 4 and it goes up value of 1, 2, 3, 4. That flips over to here, becomes 4, 4. Okay, so we're in this value here would get flipped over to this side here. Okay, and so on and so forth. So what this does, by making the function y equals f of minus x, it reflects the original function in the y-axis. Okay, so now we'll go and we'll have a wee look at the next one. Not many to go now, I think just another two after this. So as I noted there, that if we have f of minus x, then that will have the effect of reflecting the function in the y-axis. Okay, so the next one is number 5. So again, I've picked another function here just to mix it up a bit and make it a bit more interesting. So if we had a function y equals f of x, which equals sine x, and we were to take the function f of x and multiply it by a constant k, then we would have, in this example, we'd have y equals k sine x. So for an example for that is we could make k equal 2 and we would have y equals 2 sine x. Okay, so we're going to multiply a function by a constant there, or outside the function. So let's have a look and see what happens when we go and do that. Desmos, and there we go. So I'll clear these off and we'll put in y equals sine x. So there's a function y equals sine x. I'll lift it up a wee bit. Now what we're going to do is we're going to change that function so it looks like y equals some value k sine of x. Okay, now we can pick a value for k. Now the example we gave there was we'll make k equal 2. So there's k is now 2. Okay, so you can see what happens here is it stretches the function horizontally. So each value of the function, in this case, goes up by a factor of 2. So that would, at that point there, this function has a height 1. But the new function is going to be 2 times that, so it's going to have a height of 2. Okay, so it stretches the whole function. You can see that if I make it bigger and bigger, you can see the function getting stretched on the y-axis. Okay, now whenever I make this smaller than 1, what happens is that the function gets compressed. Now you can see the function getting compressed till eventually when it gets to 0, obviously it will be 0 times the function, which will give us 0. Okay, you won't give anything, and then when it goes negative you see the function flipping in the axis. Okay, so and it stretches it in the negative sense. Okay, so there you go. So that's what happens. The function gets stretched along the y-axis or up the y-axis. So that's the second last one. We'll go on to the final one now. So let's have a look and I'll bring it up, and yeah, that's us. So as I noted there, we take our function f of x, if we multiply it by a constant k, then that has the effect of it stretches the function vertically when k is greater than 1, and it compresses the function vertically when k is less than 1. Now the final one here, let's say we've got a function y equals f of x equals sine x, and let's say we say what we're going to do is we're going to take y equals f of k times x. So now the k is no longer outside the bracket, the function here, the k is actually sitting inside it. So we've got f of kx. So for example we would have y equals sine, and every time you see an x you replace it with a kx, so it's now no longer sine x, it's sine kx. So an example for that would be, say, k equals 2, then we'd have y equals sine of 2x. So let's have a wee look at this and we'll see what this does in our graphical calculator. So let's see, it's sine x and it's inside. Okay, so there's a graphical calculator. So we'll get rid of these, rid of that. So y equals sine x. So let's now replace that by y equals sine, y equals sine of k times x. Okay, now again we can choose this slider here, and that's the original function y equals sine x. We get the slider here. Now if k is just equal to 1, we just got y equals sine x. So look what happens when we make k positive. You see it's compressing that function. It's compressing it in the x-axis. So it's getting, the function's getting narrower and narrower as we head up there. We actually say the frequency is increasing, but we don't need to bother about that. But you can see there, when k is greater than 1, it's compressing the function. Okay, it's making it narrower. And then we come back there just to the original function, which is k equals 1. Now when we make k equals less than 1, it starts to make the function wider. It actually stretches it, so you see the function is the original one's green and the new one's in that kind of black colour, and you can see it get wider and wider, and you can see it wide there, until eventually if you make it 0, it just disappears there. Okay, so we don't need to bother about that point, we just need to bother about this point here. Okay, so you can see it getting stretched. Okay, so when k is less than 0, you can see the function getting stretched. Okay, and we'll no bother with the point whenever it's actually k is minus. We'll only go from the point when k equals 0 to 1. Okay, and also from 1 and above. Okay, so that's all there is to these videos. What you can do is you can download this software package and you can have a wee play about with them, and you can experiment with it. You can see the different compressions and stretchings and the reflections in the x and y axis, and all of the 6 examples that I've gone over. Okay, so thank you for listening, and goodbye.